This conference will now be recorded.
Hi everyone, welcome to Isha Training Solutions. So we'll wait for 2 more minutes for others to join and then we'll start our discussion. 2 minutes we'll wait and then we'll start our discussion, guys. Thank you. Once again, welcome to Isha Training Solutions. So, so what happened yesterday? We discussed about the course content that we are going to cover as part of this learning. Today, what we are going to do, we are going to start our topic 1 introduction session. We are going to start. So thanks for joining. And if you have any question, please stop me at any point of time and ask your question. That is very important because whatever the learning that we are doing, we should understand each and everything in a detailed way. There should not be any assumption. There should not be any take it for granted situation and all. You have to understand each and every logic, and then we have to move to the next topic. So stop me at any point of time and ask your question, and then we'll move on, guys. Okay, so first topic is actually your introduction part, performance engineering introduction part, because that understanding is right now missing. So that is what we are going to cover it right now. Okay, so performance engineering means what? Okay, engineering. Okay, you are trying to engineer something, optimize something, fine tune something. That is where engineering concept is actually comes into picture. Okay, so traditionally what happens and now what is our expectation, all things we are going to discuss now. So performance engineering, you are trying to not only provide numbers. Okay, say like response time is so and so, your cpu utilization is so and so, your memory utilization is so and so, like that. Don't only provide the numbers, you try to provide reason for the numbers. That is important. Okay, everybody is expecting that, right? You cannot say response time is more than 10 seconds, cpu utilization is more than 90 percentage, memory utilization is more than 90 percentage, like that. You cannot only say reason. Yeah, sorry, you cannot only say number. Okay, you have to tell the reason for it. That's where the engineering concept is actually comes into picture. Okay, no more people are expecting you to only provide numbers. No, no, the trend is actually changing. Everybody is actually expecting you should do little more than the expectation. Okay, so traditionally if you see, say we will test a particular application with the so and so user load, and we'll say this is what the number, response time is this much, error this much, exception this much. That's all. Okay, but the expectation is actually very very high nowadays, because you should you should actually find the reason for the issue. Okay, yes, nowadays even people are expecting little more than that also. Concepts like site reliability engineering, or uh, observability, or chaos engineering, like that. The trend is actually moving little more than that. Okay, you cannot survive with only what you are doing it right now. You have to do little more than that. Even typical example is those who are working for more than 6 to 8 years in a particular team. Okay, more than 6 to 8 years in a particular team, and still if you are saying like I know only LoadRunner scripting, or I know only Jmeter scripting, like that, if you are telling, they'll say no, no, you have to do little more than that. Try to focus on other layers as well. They'll say like, why don't you do client side measurements, why don't you do infrastructure measurements, like that. They'll ask you to do little more than that. That is where the performance engineering concept is actually comes into picture. Okay, so that's where the optimization or fine tuning or the capacity planning, all things are actually comes into picture. Okay, performance engineering, it's trying to engineer your problem. Okay, you are trying to find root cause, optimize, resolve the problem. That's where performance engineering is actually comes into picture. Performance testing is, yes, simply you are going to use the tool, hit the application with so and so user load, and you are going to say like, this is what the number that we received from the tool. Or even sometimes people will say, this is what I understand from the result. But now the expectation is little more than that. Why don't you tell me, say the response time is actually 10 seconds, like that. If somebody is saying, why don't you tell me where the 10 seconds is actually spent? Is it actually on the client side level, on the infrastructure level, on the database level? Where? Where the problem is actually happening? Okay, either you use APM tools, or you can use profiling tools, or you can use client side monitoring tools, DB profiling tools, whatever. Okay, whatever. But the end goal is what? You are trying to provide a detailed reason for why the problem is actually happening, why the problem is actually happening. That's where performance engineering concept is actually coming. Performance engineering concept is actually coming. Okay, so now that is what I told you. The expectation is actually, that one means we have to equip ourselves. We have to equip ourselves in such a way. Okay, so you have to equip ourselves in such a way that we will be in a position to do all these activities. Okay, either you are going to do focusing on infrastructure side, database side, application side, client side, whatever. Okay, whatever. Okay, so which means that what your non-functional requirements, what is your NFRs, non-functional requirements, your throughput, latency, or your memory, all these area you are going to focus on. And end of the day, what you are going to do, you are trying to optimize your application performance, fine tune your application performance. That's where performance engineering concept is actually comes into picture. Okay, because say we all know, right, the importance of optimizing the application and all, we already know. Because you cannot make your application working slow, right? I mean, you cannot accept application with the slow performance and all, right? So obviously your end user will not be there with you if you are having a poor application. Okay, say a typical example is retail based application. Retail based application, if your performance is very very poor, they'll find another retail based competitor. Okay, so it is very very important that you are going to maintain your application with a good performance. Even application availability, that is also an important factor, right? Your, if your application is actually facing some problem because of these reasons, means that is also degrade your reputation. Okay, your credibility, you are not going to get a good credibility, because your application is not actually working fine. Okay, even you need to spend a lot of money if you are not focused on your application performance in the early stage itself. In the early stage itself, if you are not focused on your application performance, in the later part, you have to spend a lot of money to do that optimization. That is very important, right? Say you think like this. So you're developing an application from the scratch level itself, and if you are not focusing on your application performance in the early stage, and if you are keep on building that application, say like 3 years, 5 years, or more than 5 years, you are developing that application, and one fine day if you wanted to optimize the application performance, means look at the investment that you have to do to optimize the application performance. It's very huge. It's very huge, because in the early stage, if you are spending, that is actually value add, but in the later stage, if you are trying to optimize your application performance, all the way you have to spend a lot of money to optimize it. You will not believe, I worked for one of the application where 100 developers are there. 100 developers are there, and that application is actually a 10 years old application. 100 developers are there, and that application is actually 10 years old application. Okay. So once they started realizing their application is actually very, very slow, the technology that they used is actually old, they are unable to cope up with the latest need of the market, then they decided to do their application optimization logic and all. But it was very, very, very huge investment when they started thinking about that optimization. So that is the reason I'm saying it is also involved with money. Okay, if you are not doing it in the early stage, in the later part, you have to spend a lot of money to optimize your application performance. Application performance. Okay, so that's where this importance of performance engineering is actually comes into picture. Okay, importance of understanding the performance engineering or proposing this performance engineering to someone is also important. Okay, it doesn't mean that you are going to do everything, guys. Okay, always this false assumption is actually there with the people. They are thinking like, how I will do all these things, where I will start, where I will focus, like that. Everybody will ask these questions, but what I'm saying, wherever it is actually possible, yes, you are going to do it, or you are going to instruct somebody or request somebody to do it. That is how the engineering is actually going to happen. It doesn't mean that everywhere you are going to do everything, right from starting till the ending. You are not going to do everything, guys. Okay, but in this course journey, what we are trying to do, we are trying to bring that awareness or understanding of where and all performance engineering can comes into picture, so that you can expand your knowledge and contribute yourself in each and every layer. Okay, because that understanding is important. Okay, you cannot blindly go with certain understanding, right? At least you should have a fair understanding where the problem is, what is your problem, where to focus on, to whom you should interact. All those understanding is very, very important. That is the reason we designed this course content in such a way that you will be having a foundation or the understanding about where and all the optimization, where and all the fine tuning, where and all the capacity planning, everything you are going to learn in this course journey, guys. Okay, so now we have a fair understanding about performance engineering means what. Performance engineering means what. Okay, performance engineers, what they are trying to do. See, I'll ask you, I'll tell you the same thing also. You can ask me a same question, sir, why this cannot be done by the developer or what? This cannot be done by the developers or what? Actually saying yes, they have to do it, but if you think from their perspective, already they are doing a lot of work. Okay, they are doing lot of work. They are working for release level activity, development activity. They are working with integration testers. They are working with user acceptance testers. They are working with production support team, deployment team, build team, client side, business analyst side, like that. Already they are doing a lot of work. Already they are interacting with multiple people, stakeholders to run the show. Still you are expecting them to do this work. Sometimes they'll say no. They'll say no. Even that cultural problem is actually there also in the current situation, guys. Okay, even the team wherever I'm interacting with nowadays, the culture is actually moving towards site reliability engineering, right? Site reliability engineering. So say like a SRE person is actually going and talking to a development team guy. Why don't you fix this? Why don't you do this? Why don't you do that? Like that, they'll say no. No, I cannot do this. I don't have time to do all these things. I'm focused on some other activity. you try to do it or you recruit somebody to do it, like that they started telling nowadays. Because I'm not blaming developers, but their situation is like that. Okay, they are focused on other activities, so they cannot do extra, that they cannot do all these additional activities because they are focused on some other activities, release level activities or sprint level activities they are already doing. Okay, so that is where performance engineering or a performance engineer role is actually coming. Why? Because developers are actually focused on something else. They have their own priorities, their own deliverables, their own activities to do. So in that case they cannot, they cannot focus on all these things. So that's where performance engineers are actually coming. Their primary activity is what? Application performance optimization, application performance tuning, capacity planning. All these things are actually done by the performance engineers. Why? Because the performance related activities are handled by the performance engineers. Developers are actually handling their release level activities. That is where performance engineer role is actually comes into picture. In certain organization, what they are doing, the same activity, still the same activity is actually performed by the developers. They are doing that. Actually, in certain matured CMM level 5 companies, these activities are still done by the developers, and they are calling themselves as what? They are calling themselves as either architects or they are calling themselves as DevOps engineers. Okay, so which means that in certain organization this is actually still done by the developers only. But if the developers they are unable to do all these activity, that's where a role of performance engineer is actually comes into picture. Okay, I'll take a pause here. Any question guys till now? Yeah, so that is the reason we are also going to start these activities, guys. I summarized in different angle why we have to learn this performance engineering, or what is performance engineering also. Because I told you, if you are only simply testing the application, and if you are only telling this is the number, response time is so and so, I received 4 error, I received 1 exception, like that, if you are simply telling that number alone, nobody is actually expecting nowadays. Nobody is actually expecting that activity alone. They are expecting little more than that. You I don't know how many of them, um, okay, I don't know how many of them encountered this before. Okay, if you are telling like my search transaction is actually taking 10 seconds, or my purchase transaction is actually taking 8 seconds, like that, if you are telling these numbers, um, um, if you are telling these numbers to uh, your development team, they'll say, boss, I have lakhs and lakhs of line that are there for this particular functionality, and if you are simply saying it is actually taking 10 seconds, it is actually taking 12 seconds, like that, where will I go and fix the issue? So they are expecting little more pointed, they are expecting little more pointed findings and recommendations. Okay, don't only tell me a generic recommendations or generic findings, that is that they are not expecting. They are expecting little more pointed information. That's where we need to do little more work to do that kind of a issue identification, guys. Okay, so you need to spend additional effort saying like, yes, this is the response time. I analyze this heap dump, and I analyze this thread dump, I analyze this garbage collection, I analyze the infrastructure metric, I analyze the database metric, I analyze the client side metric. This is what is actually happening. This file is actually taking time, this call is actually taking time, like that. You need to provide additional information. You need to provide additional information. That is very important. You cannot blindly say so and so response time, so and so things that are happening, like that. If you are blindly telling, the developers or the stakeholder, they are not expecting that. They are expecting little more than that. They are expecting little more than that. That's where the concept of performance engineering also comes into picture. That's where concept of performance engineering actually comes into picture. Okay, I'll take a pass here. Any question guys still? No. Yeah.
Yeah,
So
Sharon, sorry.
yes, Viresh.
Yeah, Sharon, yeah, I'm just generic. I mean, yeah, I mean, you mean to say like it's also as a performance engineer now, it's important to, get the root cause, like what part of the code or what functionality maybe, having that particular issue and go back to the developers and, show that
Yeah,
maybe.
you try to provide little more insight about your problem. Okay,
Right.
because simply we cannot say on a high level. See, I don't know in certain organization what they are saying. If you are, I'll tell you the scenario like this. You are spending some 5 days for requirement gathering. You are spending 5 days for scripting, and you are spending some 3 days for execution. After 13 days, you are going back and saying search transaction is actually taking 10 seconds. They'll say,
Yeah.
boss, the day one, if I use Chrome DevTools, I can say it is actually taking that much time. Why you are saying after 13 days?
Yeah.
That question they'll ask, right? Because if you are simply saying this number, definitely they'll ask this question. But you need to provide which call, which
Yeah.
URL, which method, which class, which object. Like that, if you are trying to tell them, that is actually value add for them. You're able to
Yeah.
understand, right?
Yeah. Yeah.
That is
Yeah.
the
Sure.
reason I'm
Sure.
saying. Yeah, that is the reason I'm saying performance engineering concept is actually comes into picture. Okay, so going forward, after going through all these contents, what uh, uh, primarily the benefit that we are going to get it is that we are going to approach things in a little different way, and you are not going to only say high level about this is what the problem, this is what is actually happening, kind of a things. Instead, you are going to apply your understanding, try to focus on the reason side instead of problem side. You are going to focus on the reason side, and you are going to tell them, yes, I'm able to get these understanding also. Why don't you focus on these aspects so that you can optimize the problem, like that you can explain to them. You're able to understand.
Yeah. Yeah. Sure.
Yeah. So the next one is actually um, performance engineering life cycle. Performance engineering life cycle. Okay, any activity that we are doing, there is a life cycle. Okay, I told you before also the same thing. When you are trying to do a development activity, software development life cycle, SDLC. When you are trying to do development activities, software development life cycle, they are following. When you are doing a testing, software testing life cycle you are going to follow. When you are doing performance testing life cycle you are going to follow. Similarly, here our learning is actually performance engineering, so we are going to explain about performance engineering life cycle. Performance engineering life cycle. So I wanted to explain inline to what actually your developers are actually doing, what your developers are actually doing. Okay, so when the developers are actually focused on, okay, when the developers are actually focused on requirement gathering. Just a minute. Yeah. So when the developers are simply focused on development side of requirement gathering, because they wanted to understand, uh, they have to digest these information, convert into requirements, and then they are going to develop a particular screen. Okay. So what I'm saying, SDLC in software development life cycle, when when the developers are, they are focused on requirement gathering side, means a performance engineers, they can focus on same requirement gathering, but they'll try to focus on system sizing related information also, system sizing related information also. Okay, they are going to think through, like, to arrive at a right number of resources to provide satisfactory performance to the end user. Okay, what is your proper configuration so that the end users are going to be satisfactory? Okay, they are going to have the satisfaction under what configuration level? Even they can focus on the response time related attributes. Even they can focus on number of concurrent user, those who are going to use your application. Even they can focus on the critical business flows or the business transactions that are going to be used by the end user. Even they can focus on the growth rate over the period of time, next 6 months, next 1 year, next 5 year, how the growth rate will be, like that they can focus on. Even they can focus on requirement of storage, how much data that we are going to store. Okay, daily basis, hourly basis, weekly basis, monthly basis, like that also they can think through. So in the early stage, when the developer is actually thinking about collecting the requirement to develop the application, performance engineers, they can parallelly think about system sizing related, how the system should be, what is our configuration, what is our storage, what is our growth, when we are doing the so and so transaction, what will happen when we are processing the so and so transaction, what is our response time, like that. Requirement gathering side they can focus on, requirement gathering side they can focus on these aspects. What the performance engineers will do, they will focus on these attributes, they'll focus on these attributes. That is what the primary understand. Okay, first requirement gathering when the developers are doing, in parallel performance engineers are actually trying to gather these informations, they are trying to gather these informations. Okay, next stage is what, when the developers, what they will do, developers they will do a architectural review, they'll do a architectural review or design review, whatever you call that as. Okay, similar time on the same line, when the performance engineers, what they will do, performance engineers, they'll also try to do the architectural review. They'll think about scale in scale out concept and all. What is scale in, what is scale out? Anybody heard about this term before, scale in scale out?
I think scaling in is increasing the like configuration. Say for instance, like increasing the RAM from 5 GB to 10 GB.
Sorry,
Not sure.
your voice is actually very low. Could you please repeat that answer one more
No,
time?
no, like scaling is increasing the RAM, something like that.
Okay, okay,
It's a
Yeah,
guess.
scaling when you're talking about uh, scaling out, you're talking about horizontal scaling. That's adding more machines to the system. And when you're talking about scaling, you're talking about vertical scaling. That's increasing more power. That's yeah.
yeah, yeah, correct. But uh, I think somewhere it actually deviated, that this description is actually came in the right direction, somewhere is actually moved a little. So I'll try to draw a picture. Okay, so that uh, we'll see we are in line. Okay, so say like we have a 4 GB RAM machine. Okay, 4 GB RAM machine. Okay, suddenly we are encountering some problem and we are getting the recommendations to increase the RAM size from 4 GB to 8 GB. Okay, we are getting the recommendation increasing the RAM from 4 GB to 8 GB. Still we need little more improvement. So we are putting the, we are trying to increase it from 8 GB to 16 GB. Still we wanted to get little more improvement. So we are increasing from 16 GB to 32 GB. So like this we are increasing. Okay. So after some point of time, your motherboard or your chipset will not support for increasing the RAM size and all. To an extent only you can increase it, right? So which means that at a point you are stopping your upgrading, okay, RAM increasing, okay. So this concept is what? This concept is scale in, okay, scale in, or you call that as what? Vertical scaling. In a vertical way, you are increasing your configuration. At one point of time, you are unable to increase the configuration in the single machine itself. You are unable to increase the configuration in the single machine itself. In that case, what will you do? You will create the similar kind of a copy and put it under load balancer. You are going to create a similar kind of a copy and trying to put it under load balancer. Trying to put it under load balancer. This is actually what? Scale scale out or horizontal scaling. Well, and you are telling the same thing only, right?
Yes, it's the same thing. Yeah.
Okay. So everybody in line with this understanding, right? Any questions, guys?
Yes. Like, what about the memory?
What about the?
Memory,
Sorry, I
memory.
lost you.
No, no. Like, I understand that. Okay, it is memory, right? So what about like CPU? Like,
See, anything. I just explained with the resource, one resource. Okay, it can be anything.
okay.
Okay, you are spinning up with the, see, nowadays the cloud concepts and all coming, right? So everywhere if you go, definitely people will talk about horizontal scaling, vertical scaling concept. Everybody started talking. So that's the reason I wanted to explain that, irrespective of CPU, irrespective of memory. Okay,
Okay.
even you can scale it based on your cores, based on your RAM size. Okay,
I have a question, Savannah.
yeah, well,
I have a question. Okay, so if we're adding more machines, is the RAM supposed to be the exact size of the first one in the first machine? Like 4 GB, the next machine that we're going to be adding from your diagram, is it supposed to be exactly the same size?
sorry, could you please repeat your question? What is that?
I was asking if we're going to be scaling out, horizontal scaling, okay, is the new machine that we're going to be adding going to have the same exact specification
See, there
as
is
the
no
first
condition.
one?
There is no condition that you have to do that. Okay, it is all under
Okay.
load balancer. That is the concept. Anything can be of any configuration. Okay, but most of the time, what people will try to do, it is a mimicking of the base. Okay, it is the clone of the base. Okay, that is the reason I mentioned in this way. But it's up to how you need that configuration. Okay, so it is all case to case, Valan, but mostly people will try to copy or clone the machine which is actually the first machine, and then they'll try to do that. That's the reason I put it in this way. Okay,
Okay. Okay. Thank you.
yeah. See, there are a lot of
Shravan,
logic behind that. Yes, 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 Viresh.
yeah, sorry, maybe it's too early, Shravan. I'm just want to touch base on that because see, it depends, right, on premises and also on the cloud. Like I hardly had this experience of spinning automatically on the cloud. When we really, I hardly throughout my experience of 8-10 years, I would say like hardly had this instance of upgrading the infrastructure or increasing the RAM. Sometimes it's the infrastructure team, they say, come on guys, we are getting 100 users more when the migration is happening and stuff like that. They just add more RAM into the machines and then just allocate to the users. But for example, when we had some issues, maybe for example a memory, a particular transaction or a scenario which is consuming more of the memory, at times it is not just it's not relevant to just to increase the RAM and run the show, right? It may be the fix the bottleneck issue, and that may even run the application smoothly with the same infrastructure. Like maybe 8 GB RAM is sufficient. Just because of some issue, we can't suddenly just go for 12 gig of RAM and then make sure that, oh, okay, now there is an availability for an application, right? It is first finding the root cause and then think of infrastructure side, isn't it? Sarah? Yes.
Sorry, uh, Viresh, I lost you in
Yeah.
the middle. So see, I could get the part of your question. So
Yeah.
it doesn't mean that always increasing the infrastructure will resolve your problem. Okay, that is what you
Correct.
are trying
Yeah.
to ask me, right? So
Yeah.
yes, point is valid. It doesn't mean that increasing the infrastructure will always resolve the problem. No, nowhere it is actually the truth. But it is trying to we are trying to postpone the issue. That is where we are doing this increase of infrastructure. Okay, so say like today a problem is actually happening. If you are increasing the RAM size of the CPU core, we are trying to postpone the issue to tomorrow or day after tomorrow. That is what this configurational increase is actually basically doing, but it is not resolving the problem. The root cause may be something else. The root cause may be a poor code. The root cause may be something else also. Okay, but for now, this horizontal scaling, vertical scaling and all used for trying to postpone the issue for some time. You got it right, what I'm saying?
Got it. Yeah. It is
Yeah,
like
but
putting a band-aid for a patient for a temporary
yeah,
fix and then do
but
the
yeah,
surgery
correct.
later. Yeah.
Yeah, correct. So because even any proposals where I'm going, okay, any proposal that I'm going, uh, definitely this question customer will ask. Usually they are asking what they are asking. It is a cloud environment, right? Why you are doing performance testing? That question every customer they started asking. But doesn't mean
Correct.
that
Yeah.
it doesn't mean that cloud means performance is not required. There is no hard and thumb rule that you should not do it, right? Like there is nothing like that. Because even if you are having a um, I'll tell you an example. One of the um, government project, Indian government project. Okay, so what happened? They use the scaling concept. Okay, so with the so and so user, say like 1,000 user, you think like this. Okay, say 1,000 users, they got one cloud usage, and when they are increasing from 1,000 to 1,100 or 1,200, that infrastructure automatically spinning up, and then it is going somewhere with a higher cost. The cloud is actually spinning. But as a technical person, what they told, application is working good, then what is your problem? But the government side, that guys are asking, why should I spend this much money for the cloud? Okay, you tell me, the same 1,100 or 1,200 user, I have to use it in optimized cloud credits. I don't want to spend whole lot of money for cloud infrastructure itself. Okay, so it doesn't mean that your application is working good with 10 GB or 100 GB of memory. Means you should understand first why it is actually taking 10 GB or 100 GB. Why it cannot be done with 1 GB or what? That is where the focus area. It doesn't mean that scaling is actually a solution. It is not a solution. It's actually something that is trying to work around. Okay, you are trying to do the workaround. End of the day, what you have to do, you have to find the root cause. Why this auto scaling is actually happening, why the memory usage is actually happening, why the cpu is actually happening like that. You need to investigate. That is where the actual root cause analysis. Auto scaling or this horizontal scaling or vertical scaling is not a solution, guys. Everybody able to understand? Okay, so I think the learners who joined today for evaluating us, the learners who joined today for evaluating us, please reach out to Kumar sir. Just a minute, I'll copy paste his number in the chat.
Saravanan, I have a question.
Yeah, sorry guys. Uh, yeah, you ask your question, please.
Yeah. What will be the next step, Saravanan? Like, what will be the next action? Like after you said like vertical scale. I mean, the scaling is not the problem. Like, what will be the next step? Say, for instance, in this, there are some multiple releases, and in one release they are suggesting for vertical scaling. Like, what will be the next step? Like, will they analyze
That's
on the
where,
basis of?
yeah, yeah, Vignesh. Sorry. So that's where this memory analysis or your thread analysis and all comes into picture. Your memory is
Okay.
actually keep on increasing for so and so activity, and you are finding it and you are telling it to the development team. But instead, simply if you are having this page loaded multiple times and you are getting the memory utilization going like anything, which means that the content that is actually loaded or the code that is actually used or the logic that is actually implemented is actually having a problem, which is actually unwantedly using certain memory. Why don't you optimize it like that? We can provide our findings and
Okay.
recommendations to the development team, Vignesh.
Okay.
Yeah, sure. So I pasted Kumar sir number in the chat. You guys can take it, and I also copy paste this course content link in the chat as well. So I told you yesterday also, this course is actually designed for the learners, weekend learners. Okay, Saturday Sunday we are going to have the session 6 p.m. to 7:30 p.m. IST, 1.5 hour Saturday, 1.5 hour Sunday. Okay, correspondingly in other locations, US UK locations. Okay, so 25 plus hours of session we are going to have it, and all these sessions are actually recorded, and we are going to share this video in the YouTube playlist URL. And if you are missing the session because of unavoidable situation, so you can watch the video and then you can come back with your questions. And all artifacts, supporting documents and everything we are going to share through Google Drive, so that you can download, set up the sample application in your machine. So all interview related questions and everything, industry standards and everything, we are going to discuss in this course journey, guys. Okay, already we started, but we are opening up for the learners for evaluating us. That's the reason. So once the regular sessions are actually started, we'll be having a 1.5 hour session. So that's how it is actually designed, guys. Okay, so for the learners who joined today for evaluating us, please reach out to Kumar sir for any further information. 8019924227 is number. You can reach out to Kumar sir for any further information, anything related to course timing, course content, or fees related, anything that you wanted to discuss, you can discuss with Kumar sir. Uh, uh, Pretty much we started already, but we wanted to give that opportunity for the learners to evaluate us. So that is what we had it today. So thanks for the learners who joined today for evaluating us. Thanks for giving me this opportunity. Thanks all. Bye bye.
Sarvanan, I have a question. Sarvanan, you are there?
Yeah, Anjali, please tell me.
Yeah, I mean, it is my project related. I'm not understanding what will be the solution to this. So if I mean, if we have the personal call, or can we go ahead in this call?
Please, please, we'll
Yeah.
we'll discuss. Uh, Probably I'll give you a message right after this. I have
Okay.
another session, so
Okay. Okay.
we'll
Fine.
we'll discuss in after my session. Okay.
Sure. Okay,
Thank you.
sir.
Thank you, Anjali.
Just give me your ping, then I'll call you.
Yeah. Sure,
Thank you.
Anjali. Yeah. Thank you.